Hello, madam.
Yes, sir.
Yes, sir. Shall we start?
Yes, sir. Shall start? Yeah. So, dear participants, we have the 6th day of our Atal online FTP program on sustainable engineering and carbon neutrality. We have next session by Sri B.V. Subhash Babu. Sri B.V. Subhash Babu, he's working as registrar in Energy Management Center. He holds MTech in Propulsion Engineering, MBA in Operations and HR Management, and BTech in Mechanical Engineering. He is also a BEEE certified energy auditor. His key areas of work include various capacity building programs, energy auditing, HR management, and administration of overall activities of EMC. He had worked in TTK Healthcare Limited, Chennai as mechanical engineer, Kerala Feeds Limited, Thrissur as maintenance engineer, and VSSC Trivandrum as technical engineer prior to joining EMC in 2018. He was also the coordinator of activities related to Kerala State Energy Conservation Awards from the year 2008 to 2019. He has conducted several awareness programs and innovative training programs related to energy conservation. He led the pivotal role of many schemes and activities of EMC, such as LED bulb repairing programs for differently abled students, energy clinic, smart energy programs, international training programs, etc. He is also the resource person for training programs for industries, LSGs, and government offices, educational institutions, etc. I welcome Sri B.V. Subhash Babu to take over the session. Welcome, sir.
Thank you. Am I audible?
Yes, sir, you are audible.
Thank you. Good evening. Myself, Subhash Babu, Registrar Energy Management Center. And you might be heard about Energy Management Center. Though for those who are not yet heard about the Energy Management Center, I will just tell few words about Energy Management Center. It was established in 1997, and the Energy Management Center is the institution which is dedicated operations in energy conservation and energy efficiency. And it is one of first of its kind of institution throughout the country. Actually, it is first established in 1997. At that time, actually, there was no rules for energy conservation, energy efficiency, and that. At that time, state took a brave step and futuristic step to build an organization which is dedicated to energy conservation and energy efficiency. In 2001, the Government of India bring out Energy Conservation Act 2001. Based on that act, Energy Management Center is designated as the state designated agency of Bureau of Energy Efficiency, Ministry of Power, Government of India, to implement Energy Conservation Act in the state of Kerala. Based on that, Energy Management Center has devised several programs to inculcate energy efficiency and energy conservation lifestyle in all sectors, for students, for general public, and every sector of life. We have tried to penetrate energy conservation and energy efficiency perspective, actually. Okay. And in this particular session, actually, I tried to discuss with you on sustainable and energy efficiency products and material. Actually, I have made this presentation in 3 different sectors. And the first section will talk about building materials, different type of energy efficient building materials. And second portion will be dealing about energy efficient equipments inside the building. And the third part will be of an energy efficient way of designing the building. These are the in this direction our presentation will move. Okay, so we can uh, start this presentation, and I will tell you that you have already heard about my background, and since I am in the public institution where our main duty is to implement the rules and regulations which enables energy efficient building of energy efficient propagating the energy efficiency efficient buildings. So my experience and expertise belongs to that. Okay. So first to see. A critical challenge within our industry. The built environment is responsible for approximately around 40% of all global carbon emissions. Whenever we talk about global emissions, we cannot avoid building sector because it contributes to almost 40% of the carbon emission. A significant portion of this total, specifically, an estimated around 11% is attributed to the embodied carbon inherent in construction materials. This represents the emissions generated from their extraction, manufacturing, transport, and construction. This issue is particularly relevant here in tropical climates like Kerala. Our high climate demand for cooling, coupled with the intensive use of conventional materials, create a dual pressure for increased energy consumption and heightened resource depletion. The objective of the presentation is to outline strategic approach to mitigate this impact. By reevaluating our material selection, we can fundamentally reduce our environmental footprint, future-proof our building environment against escalating climatic and resource challenges. The issue of material emission is not just an industry threat. It's now a matter of global, national, and local policy. This chart illustrates a critical point for all new constructions between 2015 and 2050. Approximately 90% of the building's carbon emission will come from directly from its material. In highly energy efficient new buildings, the operational footprint is greatly reduced, making the embodied carbon the dominant factor. This reality has prompted mandatory policy changes at every level. Nationally, we have the Energy Conservation and Sustainable Building Code, ECS-BC 2004. Earlier, it is known as Energy Conservation Building Code, and Kerala is the first state which is published in the Gazette, the Energy Conservation Sustainable Building Code in the country, which sets a new energy conservation standard, and the Eco-Nivas Samhita, ENS 2004, which is especially focused on residential energy efficiency, just like our homes and thermal comfort. Crucially, here in Kerala, the ECDC rules 2025 have been gazetted, making the adoption of these standards mandatory, complete with the formal compliance process. And this is all aligned with the broader international commitment to decarbonization driven by major global accord like the Paris Agreement and the scientific directives from the Intergovernmental Panel on Climate Change, IPCC. Having established the policy drivers for change, we now need a comprehensive way to evaluate our material choices. This slide introduces a framework for sustainability based on our four critical dimensions. It's a holistic approach that goes beyond just carbon footprint. First, the environmental dimensions. This is what we discussed. A material embodied carbon. It's a water footprint and its recyclability. These factors are crucial for reducing projects overall ecological impact. We must consider the economic dimension also. We are not just looking at the initial cost, but the long-term benefits. This includes materials life cycle cost, which accounts for maintenance and disposal and the significant operational savings. It can generate through improved performance. The third dimension, health, addresses the direct impact on people. We evaluate materials based on their ability to improve indoor air quality and whether they contain harmful chemicals known as volatile organic compounds. Finally, we look at resilience. This is about building ability to withstand future challenges. Our material choices are designed for exceptional durability with an anticipated lifespan of 50 to 100 years or more. In full compliances with the National Building Code of India, NBC, and in relevant Indian standards. We also ensure their adaptability and disaster performance against events like extreme weather. We have discussed the framework for evaluating sustainable materials. Now, let's look at some key materials that meet these criteria. We are focused on the building envelope, which is the shell of the building that protects it from the elements. First, let's consider the block for the walls. Alternatives like autoclaved or aerated concrete blocks, hollow clay blocks, and compressed stabilized earth blocks have significantly lower embodied energy than conventional ones. They are not only resource efficient but also provide better thermal insulation. Next are cool roofs. Materials with the highest flux index. We used to call it as SRA value, typically about 78, reflect high facing the heat absorbed will be reduced. The peak cooling load by 10 to 15%, directly translating to lower energy source. For windows, advanced glazing is crucial. We use low emissivity and separate selective coating that blocks unwanted solar heat while sitting up, allowing natural light to pass through it. This enhances the thermal comfort without compromising on daylight. Finally, we use efficient insulation materials such as rope wool, cellulose, etc. These materials creates thermal barrier, preventing heat from entering the building and further reducing the need for the air conditioning. After looking at the building, we have to focus on the single most significant source of embodied carbon, cement. That is cement. The production of conventional cement accounts for roughly around 8% of the global carbon dioxide emission. However, a range of low carbon alternatives are now available. This chart clearly illustrates the dramatic difference between carbon footprint. As you can see, conventional ordinary Portland cements has very high carbon dioxide footprint, while materials like geopolymer concrete have an incredibly low impact. We have to achieve significant reduction in our projects by using these alternatives. The limestone England cement clay offers carbon CO2 reduction. Geopolymer concrete is a game changer as it's completely cement free using industrial byproducts like fly ash and slag. Similarly, we can use fly ash blended cements and granulated blast furnace slags, which can reduce the emissions up to 60%, while also offering superior deal weight. We can also integrate recycled aggregates sourced from construction and demolition wastes, which closes the loop on our material usage and reduces the waste. In addition to the innovations in concrete, we must also consider the potential bio-based material, which is offers localized, rapidly renewable and high performance solution. The most prominent example is bamboo. Bamboo offers compactable high strength to timber, suitable for both structural and non-structural applications, including its innovative use in bamboo reinforced concrete construction. It is defining characteristics is rapid renewability. Bamboo matures within 3 years to 5 years, making it an incredibly sustainable and rapidly replenishing resources. This material has a specific Kerala relevance. It is abundantly available in locally, which is significantly reduces our transportation for. We also have a long tradition of using bamboo in our architecture, from vernacular houses to scaffolding, which supports local streets and rural economy. From an environmental impact perspective, bamboo has a very low embodied energy and unique ability to sequester carbon, actively lacking carbon dioxide away from the atmosphere as it grows. Finally, its applications are finally versatile, from wall panels, powering to the roofing and decorative elements, demonstrating its potential to be a comprehensive building solution. Building on our discussion of bio-based material, I want to highlight another innovative solution, hemp. When combined with lime and water to create a product known as hempcrete, it becomes a truly remarkable material. Its most powerful properties that is carbon negative. During the rapid growth, the hemp plant absorbs a significant amount of carbon dioxide from the atmosphere. This carbon is then naturally sequestered or locked away in the building material itself, which permanently reduces the overall carbon footprint of a project. Beyond that, the hempcrete offers excellent thermal insulation properties for walls and roofs, which is directly reduces the energy demand for cooling, a key concern in our climate. It's also incredibly lightweight and breathable. The material naturally regulates moisture, in which prevent mold and improves air quality, and this make for a healthier and more comfortable living or working environment. This material has high care elements as it perfectly suited for our energy efficient residential and low-rise building, and has a potential for local cultivation and the right regulatory framework. To conclude our look at bio-based material, I want to introduce a truly innovative future-forward solution: Muslim composite. Muslim is essentially a root structure of the mushroom, and we can grow it in the building materials. This material excels in several areas. Firstly, it's an example of waste upcycling. Muslim grows by consuming agricultural waste like sawdust, straw, and transforming it into useful construction product. Its produces its production requires very low energy as it's grown rather than manufactured in energy intensive process. Like hemp, Muslim also offers carbon sequestration. It locks carbon dioxide from atmosphere into the material during its growth. And perhaps its most unique feature is complete biodegradability. At the end of a breeding life, these material can be composted, returning the nutrients to the soil and leaving no waste behind, just like it will be a food for the plants. While tree emerging Muslim represents the cutting edge of regenerative design, showing us the sustainable construction uh, is heading towards. So, uh, now I would like to talk about more about familiar material that has been a revolution for modern construction. engineered timber. So we are all familiar with that. Its most significant advantage is carbon storage. As trees grow, they absorb and lock away the carbon from the atmosphere. By using timber in our buildings, we are effectively creating a long-term carbon storage solution. Through engineering, timber now offers incredible high strength and versatility. Materials like cross-laminated timbers, glued laminated timbers, and are suitable for multi-story compost structures, offering a robust and natural alternative to the concrete and steel. You can see an example of this advanced timber construction. This allows for a lightweight construction. The reduced weight of the timber structure allows foundation loads and significantly accelerate our construction timelines. It requires less time for constructing the building. And finally, timber has direct Kerala elements, but crucial distinction. We are committed to use Forest Stewardship Council FSC certified timbers from local plantation. FSC is an independent body that guarantees the wood comes from the responsibility of managed forest. So we can be sure it is not contributing to deforestation. This certification applies to the source, which allows responsibility as specific of a given species, like teak or acacia, making it safe and sustainable choice climatic systemic stores. Actually, that slide itself in the right side, you can see that FSC certification. So this process, if you when somebody says that we are in this thing that plantation has to be FSC certified. That why it is that these plantations where we are cultivating these plants has proper data should be there when it is being start to cultivate it. Okay, then after that, once it is cut for uses, then it should be replanted. So that it is that circularity should be there. And another thing is that then the second phase when the timber will go to the sawmill, where it is also that sawmill should be also an FSC certificate. Otherwise, if you mix these timbers with the other timbers which is not certified with FSC, then that the process is actually polluted. So that sawmill should be certified. Then traders who are trading this FSC wood, it has to have to be certified. Then only we can ensure that we are buying wood from FSC certified trader. Then only we can ensure that it is FSC certified material. Then the producer, the who are making these timbers for furniture or interior, he should be FSC certified so that he should be well known about how to use it and how to procure this FSC certified material. Those things he should understand and be certified professional. Then only it will be considered as FSC certificate. If all these four things comes together, then only we can say that we are using an FSC certified material for that efficient. It is considered as efficient, energy efficient material. Beyond innovative bio-based options, we can also significantly reduce our environmental footprint by maximizing the use of recycled and circular material in our project. This is about making the most of what we already have considered the case of steel. We can specify steel that is produced using over 90% of recycled content. Okay, so we can recycle the steel, whatever steel we don't have used, we can use it as for the new product, we can use it to recycle. This steel is often manufactured in an electric arc furnace, which is significantly reduces the embodied carbon compared to a traditional blast furnaces. And another thing is now a step ahead. Now people with electric car furnaces also now thinking about using renewable energy as their energy input so that it will become more green. Then aluminum. Aluminum is another primary example of the circularity. Recycling aluminum requires 95% less energy than producing a virgin aluminum from its own. This makes recycled aluminum a high sustainable choice for various applications. We can also incorporate glass cullet, which is recycled crushed glass into our glaze. This reduces the demand for the new raw material. And finally, the innovative products like plastic waste boards, high density plate blocks offers durable and versatile alternative for non-structural applications like frame panels, etc. Keeping plastic out of landfills and leaving it as a second life. So recycled plastic items used in the building construction have a very good scope. We have focused on the big ticket items like building envelope structure, but sustainability extends to the detail of our projects, including the interior. These choices can significantly impact both environmental and health outcomes. We can use low or non-VOC paints. VOC stands for volatile organic compounds, that's VOC items, which are harmful for the chemicals that can be released into the air long after the plane has dried. By using low VOC paints, we directly improve the indoor air quality for residents and workers, creating a healthier living environment. For tiles, we can specify eco tiles made from the recycled ceramics. This is a great example of circular economy as it reduces the need for the new raw material and minimizes the landfill waste. For instance, a local ceramic manufacturer makes take leftover tails or broken crockery and process it into a new tail, the natural tails. So, it can save a lot of energy and raw material. Natural clusters made from the material like clay and clay are excellent alternative to the conventional cement clusters. They are breathable, non-toxic, and help regulate humidity, which is a major advantage in climate like ours. They give the walls natural finish and can be tinted with natural pigments. Finally, we can use modular flooring system. These are designed to be reused or easily disassembled and installed. Thinking of interlocking carpet tiles, floating floor boards that can be lifted and moved without damage. This flexibility reduces waste during renovation and allows a longer and more sustainable life cycle for the products. We have now discussed various sustainable materials, but how do we objectively compare their environmental impact? Life cycle, actually, it can be done through life cycle approach. Using a tool called environmental product declaration, we used to call it as EPD. Think of an EPD as it is just like a nutrition label for building materials. So we can just like Horlicks or Boost, something like that. It's a nutrition label for building material. It's a third-party verified document that quantifies a product's environmental performance across its entire life cycle from a raw material extraction to disposal. These EPDs are based on international standards like ISO 14025 and EN 50904, which ensure that data is transparent and comparable. They also allow product category rules, which provide standardized sector rules for specific material type, allowing us to make true apples to apple comparison. The chart on this side is perfect example of this. It shows equity comparison between conventional or ordinary cement and LC3 cement. The reduced clinker content in LC3 shown in this chart. Exactly why this significantly lower carbon footprint, and we saw in our earlier slides also. We have established a scientific way to measure materials environmental impact through EPD. But that's only a half of the story. Economic dimension of sustainability is equally critical. This is where life cycle costing comes in. Life cycle costing is a methodology that looks beyond just an initial cost of the material. It's taken into account of all the cost associated with the product or its entire life cycle. We follow a standard methodology, ISO 15686, to ensure our analysis is accurate and comprehensive. The analysis period is typically 20 to 30 years, and it includes all relevant inputs, the initial cost of the material, the cost of the operation and maintenance, our time, even future cost of replacement disputes. All these things comes in data. For example, when we take a life cycle costing of one bulb, what we will do is how much we paid for this bulb, and in the lifespan of its operation, how much we spend on that. In that case, we will spend on that energy that is used to heat the bulb. So that also to be considered, and the total sum will be taken. That is the life cycle of steel. Throughout the life of the bulb, how much we have that beneficiary has paid for that. It is not just alone the price of the product, but to using that product we have to pay it. Including that also how much it costs. That is it. To perform this analysis will be used called NB, net present value, that all of us know. This allows to compare long-term financial performance to the different, providing a clear financial justification for choosing sustainable options that may have higher initial costs but deliver a significant long-term savings. To tell all these concepts together, we can look to our own backyard for field solutions by liberating local material opportunities. We not only reduces our environmental impact, but also support our regional economy. First, we have laterite and clay bricks, which are abundant in Kerala. Using these traditional materials in our projects is a simple way to achieve low embodied energy, as they sourced and produced locally without significant transport or processing. Next, we can explore coir-based composites. Coconut coir is a major byproduct in our state. By using it in a composite for the insulation panel, we can create a renewable or locally available material from existing byproducts. Finally, we have timber. When it is FSC certified, and I detailed in the last few slides, and sourced from sustainably managed plantations, timber becomes a truly renewable and powerful local options. Actually, that importance comes for this FSC certificate is that once we use the timber is used, then it should be replanted, and that system should be continuous. It should not stop after using it. It should be there. Either. The overall benefit of using this regional material is significant, and reduction in our transport emissions. By promoting our local ecosystem material, you can drastically lower the carbon footprint of our project. We have looked at the present and the past sustainability materials, but now let's look ahead. future of the building materials is not just about using better products. It's about using smarter tools to make better decisions. Firstly, seeing the rise of digital integration with BA, leading the system, leading the PPD databases. This means our design software can directly connect to a library of material, each with its own nutrition labels of environmental data. We can select a material in the digital model and instantly see its carbon footprint, allowing us to optimize our decisions in real time. This digital data fuels the next step, AI optimization of the material mix. Think of AI as a powerful tool that can analyze thousands of material combinations. It can help us finding the perfect recipe for the project. The ideal mix of materials that meet our goals for the long term, durability and cost. We are also ahead of the curve with policy evolution. The global trend is towards stricter regulations. We can expect mandatory EPDs and even carbon caps to come on the standards. Our proactive approach means we will prepare when these policies are enacted, giving us a significant market advantage. Finally, all of this positions us perfectly to embrace Kerala's role as a tropical test bed. Our unique climate, semi zone, and local material opportunities like laterite and fire make our region living can be at a forefront of this, actively contributing to benefiting a local innovation. So before we move on, I just concluding like sustainable materials are not optional add-ons. Optional, it is not an optional add-ons. They are central to climate resilience, energy security, economic saving, human health. Every slides we have gone through supports this trend. They are central to climate resilience because materials like LC3 cement and hempcrete directly reduces our carbon footprint. They provide energy security by making our buildings more efficient, reducing our dependence on air conditioning, electricity for the grid. They lead to significant economic saving in long term, as we proved with our life cycle cost analysis. And finally, they improve human health by eliminating harmful chemicals from our interiors, creating healthier living and working environment. This is in niche. It's core business strategy that directly impacts our future. It's a fun, it's foundational steps towards building truly sustainable growth. With that, we can now move from material resource to equipment that powers the building. So that first section, actually, in the first session is over. Now we will move to that equipment sector. So far, we have focused on how to reduce building embodied carbon by making smart material choices. But that's only part of the story. The other major factor is operational carbon, the energy a building consumes over its lifetime. Our energy efficient equipment strategy directly addresses this. The most significant energy used in this building falls into two core categories. First, we can upgrade high efficiency HVAC system, including strategic use of high performance ceiling fan to dramatically reduce our energy use for cooling. Second, smart and efficient lighting systems are single way to see. Switching to LED using smart controls can provide a huge return on investment. Third, our water heating can be made more efficient with solar or heat pump systems. Fourth, even vertical transport, our lifts and escalators can be energy efficient. Modern elevators use smart technology to conserve energy. Finally, we tie it all together with the building energy management systems. Aims. This is the brain of the building central system that monitors and controls all of those components to ensure they operate at peak efficiency. Implementing this core category is essential for truly carbon neutral. Now, we can move to specifics of energy efficient equipment. We have to start with the biggest energy consumer in a commercial building. HVAC systems. In fact, it is the largest energy eating item in the system. These systems alone accounts for 40 to 60% of the commercial buildings energy use. To address this, we have several highly efficient options. We can use VRF or VRV systems which provide precise sound cooling and high COP chillers, which are simply more efficient at producing cooling. We can also look at more advanced strategies like radiant cooling with a dedicated outdoors air system. This is a very efficient way to cool spaces by cooling surface rather than just air. For larger urban scale project, district cooling with thermal energy storage is an excellent option as it centralizes cooling production and saves on energy cost. And finally, for our specific climate in Kerala, we can't forget about dehumidification. And simple yet highly effective technology, BLDC fans, by integrating systems that specifically handle moisture and air movement, we can dramatically improve both efficiency and indoor comfort. To put all the technical details just discussed into the perspective, let's look at a direct comparison between conventional system and sustainable options we are proposing. On the left side, we have the conventional approach, orders in the standard ductwork and traditional fans. These systems are inherently inefficient with low SEER ratings and they account for 60% of building energy use. They rely on various controls, meaning they often look cool or unoccupied space. They often cool unoccupied spaces and waste energy. While their initial cost is lower, their long-time operational costs are high. So here comes that what I told that life cycle costings. You have to when procure it, you have to compare with the life cycle cost. On the right, we have sustainable approach by investing in high efficient chillers, PRF systems with high SEER rating. We drastically reduce our energy consumption. We also integrate modern technologies like BLDC fans, which uses up to 70% of less power than conventional fans, and the systems that specifically handle for our humidity. The result is a system that has a higher initial cost but deliver significantly a lower operational cost over its lifespan. This is a clear example of life cycle costing principle. After HVAC, the next biggest consumer of electricity, consumer of energy, energy in a building is the lighting system. Fortunately, this is an area where we can achieve some of the fastest and most impactful saving. Our approach is based on two key principles: using efficient light sources and installing smart controls. For light sources, we are transferring to LED luminaries, which are incredibly high energy efficient and can save up to 60% of the energy consumed by older lighting system. For smart controls, we will use daylight occupancy sensors to ensure lights are only where they are needed. We can also integrate smart dimming system using protocols like the dialing etc. bad patterns to adjust the light levels automatically through the day. In Kerala, our high daylight availability is a major asset, allowing us to implement daylight harvesting to maximize natural light and further reduce the energy consumption. The Kerala Secretariat's LED reform is a great example, achieving 65% of the energy saving. This project is being done by energy management sector. Excuse me, 1 minute. Let me have a cup of water. Okay, sorry.
Yes. Participants, if you have any questions, you can type in the chat window as well in between. Yes, sir. Please proceed. Thank you.
So we compared HVAC system. Let's now look at the clear comparison for lighting. This is an area where the choice massive on the left, we have conventional lighting like fluorescent and incandescent bulbs. These are now low efficiency technologies that produces a lot of waste heat and have sort of and have a low lifespan. Requiring a frequent maintenance. They rely on single manual switches. So the lights are often left on unnecessarily, leading to the high energy bills. On the right, we have modern LED lighting system. These are incredibly efficient and delivering over 120 lumens per watt, which is translated into 60 to 40% energy save. The real power comes from the automated controls. By using daylight and occupancy sensors, we ensure lights are only on when and where they needed. This higher emission investment is clearly required through drastically lower energy bills and almost zero maintenance as LED lasts for the tens of thousands of hours. So, actually, these things we already, this generation of people already experienced these things because we have gone through all the three types of lighting systems that is in our residential sector. Earlier it was incandescent lamps, there's filament lamps, and then there was a shift towards fluorescent lamps and compact fluorescent lamps. Then suddenly there was a shift to LED. That's, we have all of us have witnessed these changes in our lifetime. Our next category is water heating. It's another significant energy consumption. Fortunately, we can make this process incredibly efficient using solar and heat pump technologies. We have few key options. First, solar water heaters uses the sun-free energy to provide hot water. For this, we would use systems that are compliant with Ministry of New and Renewable Energy to ensure reliability and quality. Second, for cloudy days or high demand, we can use heat pumps water heaters. These are extremely efficient with a coefficient performance coefficient of around 0 greater than 3. Let's see if you have 3 means the system provides 3 units of heat energy for every 1 unit of electricity it consumes. The most effective solution for our climate is hybrid installations that contains both. You can see in the image, this system uses solar as a primary source and the heat pump as a efficient backup. This is a perfect fit for us in Kerala as we have excellent solar resources receiving 4.5 to 6 kilowatt hour of solar energy per square meter per day. This makes solar hybrid system natural and high effective choice for power. But nowadays, almost all these commercial institutions, just like hotels and hospitals, so in those areas for hot water system, They use heat pump, energy heat pump. Because the penetration of these advanced technologies like heat pumps are very high in the outset. To summarize this section, let's look at a clear comparison for water heating. On one side, we have the conventional electric geyser. This is very inefficient method as it uses electric heating element to directly heat water. This result is coefficient of performance less than 1. And it costs a lot to run. So compared to our heat pumps, it's inefficient. On the other side, our sustainable solutions uses advanced technologies and free energy from the sun. Heat pump water heaters are high zero, typically it is 3 or more. Because of they remove heat rather than creating it. The best part is the solar water heater, which is used as the sun heat, making it virtually free to operate. While conventional users have low initial costs, but sustainability systems are very low operational costs, leading to a significant savings over a long time. For locations like Kerala, it's abundant sunlight. This choice is a confident. Then we move on to 43. Conventional elevators the major source of energy waste and operational cost. Our strategy is to move to a fully integrated machine room-less system. This isn't just about more modern look. It's about leveraging the free key technologies to drive down the cost. First, gearless with VFD, variable frequency drive. These systems use up to 80% less energy than old motors. They eliminate the friction and the energy losses of gearbox. The VFD ensures the motor uses only the power it needs for the to say load. Actually, that as a lot of VFD gives that wherever there is a variable load is there, VFD can perform better. That's all of us know. Then regenerative braking. This is the game changer. When an inverter is carrying a heavy load down or a light load up, it's crucially generating energy. Our new system captures this energy and feed it back to the building's grid, power grid, creating a direct energy return. Actually, the regenerating braking, you might be heard about these systems in our cars. The same thing in a different way. That's destination control. This smart technology makes our system more efficient for both energy and people. It's group passengers going to the same floor, reducing the number of floors, travel times, and overall energy cuts. By adopting these technologies, we can achieve up to 30% energy save, significantly reducing our operational cost. This makes returns our investment compelling. It's critical step achieving high performance with sustainable yield. Actually, you might be seeing in some of the modern buildings. Usually, we can see the control system that selection of floor and inside the elevator. But in the new buildings, you can see that you have to choose where you have to get down. You have to give that selection should be made in the outside the elevator. Those things are actually made like that to give the destination control systems. That is that those elevators adapted this destination control system. I just pointed out it. Whenever you see such system, you can identify that this is used for that. When we look at our vertical transport, we are essentially comparing two systems, one that is designed to move people and one that is designed to move people efficiently. The key difference lies in the technology. Our old conventional elevators use energy wasting geared motors and outdated braking system that simply throws away the excess power as heat. They also require a large dedicated machine room which is significant waste of space and resources. In contrast, new energy efficient elevators are built around three core principles: direct efficiency. We have replaced old motors with gearless variable frequency drives. These eliminates friction and ensures more motors fully uses exact amount of energy needed to the load and speed. The second one is energy recycling. Our new these systems uses regenerative braking. When the elevators moves in a way that generate energy, it captures that power and feeds it directly back to into our building's electrical. Integrated. The last one is intelligent control. With this destination dispatch, we group passengers and reduces the number of stops, which directly translate to less energy consumption per trip. This is a leap in performance. These new systems can give up to 30% or elevated energy consumes, and this is directly reducing our bills. A significant step towards making building high performance and sustainable. And please also think that I have told you that you can see some elevators where you can that selection switches are outside. Actually, that elevators with the inside selection switches also can have this type of options. If you want to have it in a manual way, also you can do it. If in your office you have 4 to 7 lift, you can dedicate each lift to some certain floors. It will open on certain floors. So it's also a type of management system like that. But here it is automatically that with the uh, artificial, just like artificial intelligence, they will based on the scheduling and all, they will identify it. That's it. Now we have discussed the individual components. Let's look at the system that connect everything. Building controls and management. This is where we use smart technologies to optimize the performance of all our systems. Our strategy here involves a few key technologies. First, building energy management system, BEMS. We want to implement BEMS with a demand response. This isn't just a single timer. It's a smart system that uses artificial intelligence to predict energy needs, optimize schedule, and adjust our systems in real time to avoid energy waste and manage our heat loads. Second, we all install smart meters of train. This provides us with the granular data on exactly where and how we are using the energy. It's a key requirement for energy green building certification, and it gives us the data we need to make informed decisions. Finally, we integrate these controls with our solar PV plus storage solutions by linking our on-site power generation to our buildings' energy consumption. We can intelligently use our own clean power. The ultimate outcome is clear. We can perform quick load sharing to reduce our energy cost and achieve significant long-time saving. This is how we take our buildings from static structure to the intelligent high performance systems. So now there's some regulations that we have placed that is we are on that. We have established the foundation of the national building code. Let's start. Now we can say about a state what's the role of state. As the Energy Management Center, we are the state designated agency under the Energy Conservation Act of 2001. We are the architect of Kerala's specific energy roadmap for sustainable buildings. Our core mission at EMC is to drive energy conservation, and our primary tool for this is Kerala Energy Conservation and Sustainable Building Law, KESCSBC, goes 2025. This code is not just a regulatory document, it's a blueprint for building a more sustainable futures. The KECSBC is built on two key principles: the use of sustainable materials and the installation of energy efficient equipment. When we talk about sustainable material, we are focusing on building envelope. This means using high performance glazing and advanced insulation that are designed for our state's warm, humid climate. These materials act as a thermal barrier, significantly reducing the amount of energy needed to cool our building. Specific components of central ECSDC, now part of our rules, is a voluntary portion in the appendix on sustainable materials. This section refers the reporting of embodied carbon, which is a significant step towards holistic approach to building system. And when we talk about energy efficient equipment, we are referring to everything inside the building. The code mandate the use of highly efficient HVAC system, LED lighting, and the regenerative elevator. These systems work together ensure that every kilowatt of electricity is used as effectively as possible, directly reducing our energy consumption and utility bill. By making these two elements, sustainable materials and energy efficient equipment, mandatory part of CSDC, we are ensuring that every new building in Kerala is high performance facility. That we have different programs. AMC Kerala is having different programs. Accredited energy audit training, we have a dedicated program for energy auditors and energy professionals. Actually, we have different types of programs like that. And some of the program we tell you, then we have solar street lights. Not solar street light, energy efficient street LED street lights actually in national. So the first state to introduce LED street light was from Kerala. We have the first LEDs in Palakkad district when the permit was shipped. That is being executed by Energy Management Center. And we have a NML accredited lab here. There we can test, calibrate energy meters and smart meters. And we have LED testing lab. Actually, this type of lab is actually nationwide only 5 places. This lab is having. In South India, we have 3. One is in CPRI, second is in IIT Bombay, and third is in here, Leeds. And we have another program called Kulurma, where what we will do is that we promote people to use high reflective index paints in their roof to cool down their buildings during the summer. So that program is called Kulurma. I just giving us just a glimpse of it. So it is not a big program detail. Then we have EV, electric Energy Management Center is a state nodal agency for the Go Electric program. As part of that, we promote electric vehicle in the state, and we stand first in the case of rate of propagation of electric vehicles in the country, though we are not giving any subsidy for electric vehicle. So there is a penetration, percentage of penetration we stand first. And in that electric Go Electric program, our other item is that electric cooking, promotion of electric cooking. So we have one program called Angad Jyoti, where we converted around 3,000 and we have around 33,500 Anganwadis. That is a kindergarten level government infrastructure for kids. It's a first entry to the education system for a kid. Okay, there for the new there they have provided with the food, and currently we are using LPG, and so we have formed a new program called Anganwadi, where we are converting this into electric cooking system, especially induction with its compatible ports, and we have converted around 3,000 Anganwadis now, and the same program is being replicated across the nation. Different states are now adopting it. And we have actually converted on in school level also we have noon meal system, and we have converted on schools in Kasaragod, Kanana Memorial School, we have converted it into electric cooking system, electric steam based mass cooking system we have converted. That's also running successfully and will uh, replicate in the other schools also. And we have now we are thinking about a district cooling and shared cooling program. Actually, that is another innovative item. If it is happens, it will be a very huge item which can be replicated across the country. That we will have a common cooling facility, and it will that cooling will be provided by a provider to the different buildings from a single point. Just like you are receiving electricity, you will get chilled water for your cooling system. That is, we are going to try it out, and several similar programs are there. So I'm not going into detail into that. Then we are planning to net zero building by 2030. Actually, by 2040, our aim is by 2040, we have to be 100% renewable energy. We have to stand on 100% renewable energy. Our all energy requirement should be renewable energy by 2050. The state is put a target that it will become a carbon neutral by 2050. The whole state. So again, as a closing message, sustainable materials are not optional add-ons. They are central to the climate resilience, energy security, and economic saving and human health. Already I have pointed out this thing, and I am again repeating it because these presentations are made on that theme. So now I am moving to the design strategy for sustainable and energy efficient building. As we move forward, it's not just about what building is made of, it's about how it's designed. ECSDC mandates that we embrace intelligent, passive design strategies, which are cornerstone of energy conservation. Our approach is centered on the three key pillars: orientation and shading is the first one. We must use the building's placement to our advantage by correctly orienting the building and using the shading. We can control how much direct sunlight enters and drastically reducing our cooling needs. Natural ventilation and daylighting. We will be designed with open floor plans and strategic window placement to maximize natural airflow and sunlight. This reduces the need for energy intensive air conditioning and artificial lighting. The thermal masses. We can use materials that absorbs and stores heat during the day and releases it slowly at night, helping it to regulate indoor temperature. And naturally, these strategies are the first and most effective steps in reducing release energy demand. By incorporating these passive designs principles from the very beginning, we build a foundation of efficiency that will last for daily life. We have covered what and why of our energy core. Now let's look at the how in simple terms our strategies build on few straightforward ideas that is old as architecture itself, but now backed by modern sense. First, building orientation and sharing. Thinking of it like this: your building is putting on a pair of sunglasses. by placing the building to face the right direction and use the features like overhang and we can block the harsh sun. This keeps the building from getting hot in the first place and it's our first step towards the saving energy. Next, we have lateral ventilation and dilating. This is about getting the building breathe. We design space to be open and airy with windows on opposite direction side to create breeze. We also use natural light as much as possible, which means we don't have to turn on the light as often. This is simple, no cost way to make the building more comfortable and save our electricity bills. Finally, we use thermal masses. This secret weapon of smart design, which uses material made of concrete and bricks that can absorb heat during day. As the sun goes down, the air cools. The building slowly releases that stored heat, keeping the temperature steady. This means our air conditioning system doesn't don't have to work as hard, which is major win for both energy saving and occupant comfort. These three strategies are most impactful thing which can do to make a building energy efficient before we even turn on a single switch. We talked about passive design principles and now let's look at how we apply them directly to the light and heat. Our strategy is twofold. We use shade to block the unwanted heat and we use the sun to provide clean power for our light. First, shading. In our climate, the sun is both a friend and enemy. While we want its light, we don't want its heat. So we design building with built-in shade. This those pins and even strategically placed over hands blocks the direct sun from hitting our window. This simple design features dramatically reduces the work our air conditioners have to do. Second, we are promoting solar lights. We install solar panels on the roof to capture sun's energy. This energy is stored in batteries and used to power high efficient LED lights throughout the building, especially in common areas and parking lots. These clean renewable energy sources that directly cuts our electricity bill and reduces our reliance on the grid by using shading controlled heat solar panel generate power. We are making our building more resilient and self-sufficient. We have talked about how we can build more intelligently, and crucial part of that is how building breathes. ECFBC focus on two key elements to manage this ventilation and heat recovery ventilators. First, ventilation. We are moving beyond just opening window. Our code mandate that all habitable spaces have proper outdoor air supply. This ensures fresh air circulation continuously, making the indoor environment healthier and more comfortable for everyone. But we do this smartly, especially in air conditioned space. This is where heat recovery ventilators come in. And HRV is a device that captures the energy from the air leaving a building and uses it either pre-cool or preheat the fresh air coming in. This means we get a constant supply of fresh, clean air without having to waste the energy or spend on cooling or heating the air inside. By combining proper ventilation with efficiency of HR, we can maintain excellent indoor air quality by significantly reducing energy needed for our HVAC system. It's about designing buildings that are both healthy for people and healthy for our planet also. We talked about building designs and now we will focus on how we will light it both naturally and with technology. The ECSBC encourages smart approaches to lighting that dramatically cut the energy use. For our strategy is twofold. First, daylighting. This is about using natural light as our primary source of illumination. By designing with the large windows, skylights, and clerestory windows, we can fill our space with a lot of sunlight, reducing our lens on electricity. Uh, Different natural source of energy is required to make it. It's a single free and beautiful way to light every day. Second, we are using smart lighting system. This is where we bring technology into the equation. It uses occupancy sensor that automatically turns light on when a room is in use and turn them off when it is empty. And with the dimming controls, you can adjust light level based on what needs saves energy and when full brightness is necessary. By combining these two approaches, we can create lighting system that is both energy efficient and highly responsive to how the building is used. This is a crucial step in our mission to build smarter and more sustainable assets. We have talked about design, and now we will talk about materials and systems that make these designs works. Our approaches is a smart fusion of traditional wisdom and modern technology. First, let us look into thermal masses and local materials. The ECSBC encourages using materials that are naturally suited to climate. Materials like laterite, clay tile, and bamboo have been used for centuries because they have high thermal masses. They can absorb heat during the day, keeping inside cool and slowly release it at night. This is a simple, cost-effective strategy that reduces our reliance on mechanical cooling. Next, we look at efficient HVAC system. Instead of old inefficient system are either fully or on or off, we are promoting advanced technologies like VRV systems, and inverter ACs. These are incredibly smart. They can adjust their power output to match the exact cooling needs in the room. We can also use zonal cooling to cool only the occupied parts of the building. So we can never waste energy on empty spaces. By combining the natural uh, thermal properties of a local material with the intelligence of modern HVAC, we are building assets that are both sustainable and highly efficient. As we near the conclusion, let's look at our code integrates timeless wisdom with the cutting edge technology. It's about combining best of our heritage with future energy. First, our traditional inspiration. For centuries, Kerala's Nalivittu homes have been a masterclass in passive design. Their center courtyard or Nadavittals brings natural light and creates breeze, while thick walls and clay tiles helps regulate indoor temperature. These ECBC embraces wisdom, forwarding that most sustainable strategies are often the oldest. Next, we first with the renewables. We are making solar energy core part of our building. We are promoting solar PV for integrating clean energy, solar water heaters for simple and efficient way to heat the water, and even building integrated photovoltaics, where the solar panel are part of the building facades or roofs itself. By combining the passive genius of knowledge homes active power of solar energy, we are building assets that's both deeply rooted in our culture and ready to sustainable future. We have covered what's inside the building, but now let's talk about the how building interact with surroundings. Our final two strategies are about nature and technology create complete intelligent system. First, landscape integration. Our code promotes using natural landscape our advantages. By planting shade trees strategically, we can block direct sunlight from hitting building walls and windows. And by incorporating water bodies, we can create cooler, more pleasant microclimate right outside the door. This is a beautiful and effective way to reduce the need for air conditioning. Second, we are focused on automation. This is the brain of entire operation. We use smart meters to get real-time data on exactly how much energy we are using and where we are using it. This data is fed to a building management system, which automatically controls optimize HVAC and lighting systems about using data to make our building as smart and as efficient as possible. These two strategies integrates with nature, embracing automation, are final pieces of puzzles for creating truly high performance building. As we finish up, I want to leave you with a final thought. The work we are doing here today isn't just about new rules, it's about being part of the larger mission, a movement. Here we fit in. First, on a global scale, we are on the same team that rest on the world by following international standards from groups like ISO and EU. We make use of our buildings are just good as the best in the world. Second, as on a national level, we are key part of India's mission by implementing new UCSBC 2024. We are helping our country and leading the way in building a sustainable future. And finally, on the local front, here in Kerala, this is where we make it real. Our new UCSBC rules 2025 are the local forces that makes all of this happen. We have made these rules as mandatory part of getting building permit, which means every new building is a step towards greener future for our state. It's a clear path from global standards to national goal and finally to local action. And together we are making that happens. Once again, I would like to say sustainable approaches are not optional add-ons. They are central to climate resilience, energy security, economic savings, and human health. In the end, we can say that this code is not just a collection of rules, but a bold statement. It shows our unwavering commitment to a greener, more sustainable career. We are not just building structures, we are building a legacy of efficiency and responsibility for future generations. Thank you. Thank you. Uh,
Hello, sir.
Hello.
Yes, sir.
Yeah. So my presentation is completed.
Yes, sir. Thank you. Thank you, sir.
Okay.
Thank you for valuable session. Participants, if there are any questions, you can ask. Participants, if you have any questions, you can type the questions in the chat window as well, or you can ask directly.
Great.
I think there are questions, so we'll wind up the session, sir. Thank you for covering all the aspects related to that sustainable building products and the activities of EMC. Thank you for your session, sir. And in spite of your busy schedule, you have found your time for 90 minutes for this session. So we have the participant all over the India. So really they have benefited from your talk. Thank you, sir. Thank you for the session.
Thank you. Thank you for giving me this opportunity to interact with all these people, and thank you once again. Thank you. Shall I quit?
Yes, sir. Sure.
Thank you.
So participants, please fill the feedback form that I'll be posting in the WhatsApp group as well as in chat window. We can have the next session by Sri Ajit Gobi, Dr. Ajit Gobi. Sir will be joining in another 2 minutes.